COBT listeners and viewers. It's Maynard, Mark Davidson, and Mike Bradley here with something super special. We're out on the road this summer, trying to learn, trying to get outdoors, and one of the things we've had on our list of things to do is to get out to Utah and see Fervo. So we're here at Cape Station. This is a fantastic development is underway here. Eventually, there could be 400 megawatts of geothermal power going onto the grid. Tim Latimer is the CEO. He's joining us from Houston. Tim, welcome. It's great to have you. And we've also got Kareem El-Sadi. He's the drilling engineer manager here at the site. And so we have spent the morning. I left my vest on, guys, just well, it feels nice, but it gives me an air of authenticity here. But the team has been great here, Tim, giving us a tour, introducing us to so many aspects of the site, letting us understand, their various specialties and such. But it's really been fascinating. And let me just start by saying thank you. We're thrilled to do this.
No, I thank you for having us on the show and putting a spotlight on Fervo. We appreciate it. We're doing some very exciting things, and we love having folks like you out on site to show you what we're up to. And thanks so much for including us.
Well, it's great. I think everybody knows geothermal. You started the company in 2017, I believe it was, Tim. And just ever so slowly, geothermal has been creeping up in terms of people's perceptions of what's possible. And now it's really thriving. We understand you get more than a few tours of people through here. But I think one of your folks was telling us, we were talking about why do people join Fervo? And she was explaining from a technical standpoint, people feel like geothermal is getting its moment. And there's a lot of challenge and a lot of opportunity in it. And so I think that's probably what finally got us here. Geothermal is having its moment.
Yeah, it definitely is.
Mike Bradley, why don't you share with us what's happening in the world before we jump in with Kareem and Tim and Mark and myself?
Okay, Maynard, I kind of miss you guys. You're out on the road. I'm stuck in the office here, but that's all good. Now, a couple things I'd want to mention. First, on the bond market front, I don't think anybody will be surprised that tomorrow is going to be the FOMC meeting. Consensus is there's not going to be any change in rates. Now, what I would say, if the Fed lowers rates for some reason, you're probably going to have a temporary lift in markets, but then the markets are going to go into worry mode of why is the Fed cutting rates? Is Trump pressuring them, or is the U.S. economy slowing? So might be an initial jump if they cut, if they lower rates, but I think there'll be some long-term issues if they do that. So just a heads up tomorrow, there's going to be some volatility around that. As far as broader equity markets, the S&P 500 hit all-time highs on Monday. Today, we're pulling back a little bit. It feels more like, sort of sell the news on the trade front standpoint. We've got all these deals. How much better can it get? So that's what it feels like is occurring right now at these valuation levels. I think what we're looking at is over the next 2 days, we'll get 4 of the big 6 tech companies, Apple, Amazon, Meta, and Microsoft will be reporting results. It's probably going to be very AI data-centric CapEx spend heavy on those calls. So that will be a big theme for those calls. And it could affect both those stocks, the broader market, as well as some of these electricity stocks that have been on a run over the last 6 months or so. The other thing we'd say is today there was a big merger. Union Pacific and Norfolk Southern announced that they're going to merge in a $250 billion deal to form America's first intercontinental railroad. Really, really interesting that we have this coming together. And then the reason I say it's interesting is that, if you look at these tariff deals coming together, broader market hitting all-time highs, it seems like there's an ideal setup for additional mergers of size, especially with the Trump administration. So it'll be really interesting to see if this deal actually gets pushed through. You probably wouldn't have ever seen this happen under the Biden administration. Maybe it gets done under the Trump administration. So with all those factors at work, I would expect you're going to see more deals are going to be coming out of the woodwork over the next couple months. As far as the energy markets, oil service companies, we talked about this last week. Oil service companies' earnings are generally in line. 2025 estimates are generally going down, but the stocks are outperforming. Not today, but that's what's been the trend here over the last week and a half. The other thing we'd say it was interesting today. We saw basically a notable deal in the oil service industry. Baker Hughes came over the top of Flowserve to acquire Chart Industries for roughly $13.5 billion. A lot of this was it was a move from an industrial logic standpoint for Baker, and Baker stock is going a little bit down today, but we just wanted to mention that because we think there's going to be more deals that's going to happen in the oil service industry, and so this is one of the first deals out of the gate.
Okay. All right. Well, thanks, Mike. And I mentioned Mark Davidson in the upfront. Mark's a senior technical advisor with Veriton. This is also his first COP. Really excited to have you join. Mark was on the tour here today. Mark is also one of the 2 PhDs at Veriton. So we've taken corporate risk by having one of our PhDs out of the office. But anyway, Mark, it's great to have you. And I know you're going to jump in with some technical questions.
Yes, thank you, Maynard.
And Mark, you mentioned this, and Tim, we talked about it. Maybe a good place to start. I mean, I think one of the things that we've enjoyed with your team this morning is, you are drilling wells here. And so as people who are very familiar with oil and gas, we instantly latch on to that. And as people who are spending a lot of time around power, you can kind of quickly get your head around the sort of facilities. But where I noticed us spending a fair amount of time, a Q&A, if you will, was understanding what's happening in the subsurface with geothermal and understanding how it's different than what your father's geothermal, what's special about this site, how replicable this all is, how long it lasts. Like this, I think just understanding some of the foundational elements of geothermal has been where we have been spending some good time. If you think that might be a good place to start.
Yeah, let's do it. I'm happy to kind of go back to the basics because I do think it's important. We're an emerging sort of energy technology that's getting a lot more awareness, but we're still, not a household name like some of the more established energy resources. So it's always useful to start just with the beginning. And that I kind of joke is it comes down to 2 facts: that the Earth is really big and the Earth is really hot. And so there's a huge store of thermal energy in the Earth, and in certain places it comes up a lot closer to the surface. So we've used geothermal heat as humanity for millennia. People swimming in hot springs are using that for something useful. And going back over 100 years ago in Tuscany, it's the first time somebody had the idea of, well, what if there's a steam vent, what if I put a turbine on it? Could you make electricity? And that's how geothermal power was born. And for really the first century after that, it's been a relatively small industry because it has relied on incredibly unique geologic conditions. So like a lot of people think of geothermal and you think of Iceland. And why is Iceland a global leader in geothermal? It's because there's volcanic activity that brings that heat extraordinarily close to the surface. And there's unique geology that's fractured and faulted so that there can be flow of that steam to the surface as well. So for a long time, geothermal was this resource that it was beautiful where you had it. It kind of meets all these needs we're looking for in the energy sector. It's emission-free. It works 24/7. It's reliable. It's well understood. But, for most of the history of geothermal, the story has sort of been you either have Iceland's geology, where it's really shallow and fractured and close to the surface, or you're out of luck. And as a result, the energy industry is, the full geothermal industry is less than 0.5% of the global electricity supply. So important in certain locations, but not a meaningful driver. And so if you want to get more geothermal, you have to do something very different because not all these places with the perfect geology exist. And so Fervo works in the field of what's called enhanced geothermal systems. And this has been around, kind of proposed by the national labs here in the US since the 70s. People have tinkered on it and worked with it. And it's essentially the idea of, okay, what if you could use drilling tech to go a lot deeper? So you're not limited to just places where it's super shallow. And what if you could use well stimulation methods, whether it's thermal stimulation or hydraulic fracturing or something else from a production enhancement standpoint, so that you could get high flow rates out of the geothermal reservoir, even if it wasn't naturally permeable or naturally faulted or fractured. And so that's what we do. And so the basic system is we drill deep wells, and you've been out there today, so you've seen it. We pump cold water down injection wells. It sweeps across the reservoir to heat up down to those reservoir temperatures. And then we produce that hot water at the surface. And we use power generation technology, in our case, organic Rankine cycle systems. But in other examples with geothermal, it's just simple steam turbines to generate power from that. And what Fervo's done that's unique in this place is we go a lot deeper than people have in the past because we've got access to better drilling technology that people have had historically from a geothermal standpoint. We turn horizontally in the subsurface for the same reason you do in shale. It's about more bang for your buck, more resource. And then we do hydraulic fracturing to drive connections between the injection wells and the production wells, even in locations where there's not natural permeability.
So maybe one question, Tim, in your background. So you're a University of Tulsa mechanical engineer. You joined BHP. You're drilling wells in the Permian and the Eagle Ford. And then I think it was about 17 when Fervo was born. What did you see then? What caused you to say, I'm going to take this career leap and I think this could work?
Yeah, it's a great question. First job out of school, it was quite fun. 2012, the Eagle Ford was really sort of hitting its stride back then. And that's where my first job was, working on a rig down in the Eagle Ford. And interestingly enough, when you look across the onshore U.S. fields, the Eagle Ford's unique in how high temperature it is. It's not quite as hot as the Haynesville, but it's still a lot hotter than some of the other formations. And we kept having issues where we thought we were having drill bit, motor, MWD reliability challenges because it was so hot. So my first job ever out of school was, hey, these wells are pretty hot. What do we do about it? So like any engineer, I'm doing my literature review. I'd never even heard of geothermal at that point. So I got very interested in it because everything when I searched high temperature drilling was popping up all about geothermal. And the light bulb moment for me was I read a paper, and it was a report called The Future of Geothermal Energy that was published by MIT in 2006. And in the executive summary, they basically said, we have an unlimited amount of heat in the Earth's surface. But we've just struggled to tap it for really two reasons. Drilling is expensive, and we got to get high flow rates out of low permeability formations. And I'm like literally working on a project as a drilling engineer in the Eagle Ford, developing this resource that people said was uneconomic just a few years before because we would got a lot better at drilling and we were applying hydraulic fracturing to it. And the light bulb went off for me that if the major challenge in scaling geothermal is low cost drilling and getting high flow rates out of low permeability formations, like, my God, we just solved this problem in tight gas and tight oil in the United States, and it's revolutionizing the sector. So I got really excited about what if we took those same technologies and adapted it into geothermal, and the journey took a lot. It's had many twists and turns, but that was when I originally got conviction about how we could use these technologies to be very disruptive to the traditional geothermal sector.
I think those of us who've been around shale and the shale revolution were like, what a great experience, because it introduced these techniques to all of us, but it also reminded us that so much is possible, and don't rule things out. But the other one I was just thinking about is, we were short natural gas in the U.S. Prices really went high, and that really fed the investment into shale, and that eventually drove it to be a low-cost provider of gas. Do we have the same kind of thing happening now? Power prices went really high. There's a real shortage of, quote, no impact or low impact power. It created this market opportunity to kind of, quote, fund and figure out and bring the cost down of geothermal. Is that a way to think about it?
I think that's a great analogy. And I think it's true whenever you talk about sort of any emerging hardware technology is sort of by definition, when it starts out, it's going to be more expensive because you don't have the reps, you don't have the economies of scale, you're still tinkering. And so a lot of times it does take these sort of acute special market moments to make it work. It's incredible. If you were to take the sort of unconventional drilling performance, whether you want to do days versus depth or lateral length or production per foot or, proppant intensity of a 2009 well, and apply it to today's gas prices, I mean, you would never make money with it. But what it did is allow the industry to scale because there was this high price environment. And then once the industry scaled and people had the right scale to tinker and come down the learning curve and drive costs lower, when the cost collapsed, the industry was still profitable because it had gotten over that hump. And I do think there's a bit of an analogy to that right now. Our prices to develop this geothermal power is a lot more expensive today than we hope it will be 5 or 10 years from now, in large part because what we're doing, drilling long laterals in granite and hydraulically fracturing a new type of reservoir in really high temperatures is new, and so there's a lot we're learning on the fly, and we're very fortunate that, in much the same analogy to the natural gas world from 15 years ago, we're at a moment right now where power demand is so immense that you can get elevated pricing for the power if you can bring it online quickly, which we can. And I do think it's going to be something that gets us over the hump so we can get the scale needed to be an incredibly low cost resource in the future. And I think your parallel with how the tight oil and gas market evolved with shale is spot on.
One of the things we were talking about with your team, and I'll mess up some of this, I'm going to get into the subsurface a little bit, was we were talking about your wells, which are, at least out here, they're about 8,000 feet vertical depth, and then they go sideways for 6,000 feet or so. But as you mentioned, the temperature is really high. Like I think I heard we're over 400, we're 400 plus Fahrenheit down there. And I think an oil and gas well would be closer to 200. So you're just a lot hotter, and you got to deal with all the stress on all the equipment down there. But you're also, at least here, going through granite. And so there was this discussion of how the drill bits, how you figured out how to drill these wells. Again, this is kind of a shale analogy, but since you've started, you've really improved the cost, the timing. It's just, you're getting smarter and smarter. And here's my last stat I heard this morning, is that when you look at the cost of this power, 40% of it is drilling and completing the wells, plus or minus. So if you reduce the cost of that, it's a lot to do with the cost of power. But I'm looking at you, Tim, and you, Kareem. Yeah. Anybody jump in on that one?
Well, I think it's great. Well, Maynard, why don't I paint the picture of sort of where we started and why we had so much skepticism about applying the drilling techniques we've had to geothermal. And then Kareem, since he's led so much of this, I'll let him tell you where we are now. And now that we've implemented a lot of these improvements, it was interesting when we first started thinking about the company. And as you mentioned, we founded it in 2017, and we started doing our first couple of years of reservoir modeling and simulation and techno-economic analysis and picking what site we wanted to go to and going through the permits. We did our first field work in 2020, and we started drilling our first wells in 2021. And it's amazing in hindsight how much skepticism we faced about the performance. And we heard all kinds of things, like a big unlock for the shale industry has been the advent of the polycrystalline diamond compact bit, PDC bits, which can just make footage a lot more quickly than more traditional bit styles. And we heard, oh, those will never work in granite because it's too hard of a rock for a PDC. And we heard, well, you can't do directional drilling in granite because you're not going to be able to get the right curvature you need. You can't stick an MWD in the hole because it's too high temperature. We faced all of these challenges. And so when we drilled our first well at what we call Project Red in Nevada, we were just ecstatic that we drilled the well because we'd faced so much skepticism over the years that you could actually execute a horizontal well in these conditions. But, the facts of it were, we drilled a well that was about 8,000 feet TVD and a 3,000 foot lateral, so just over 11,000 feet total depth. It took us 75 days. The lateral was 3,000 feet, and we had to use over 11 BHAs in the lateral because we weren't getting a lot of extended performance in this hard rock environment. And so some of the things we sort of proved. Oh, and by the way, the drilling cost for that well was $13 million. That first well that we drilled. And the punchline is you're never going to make geothermal power work if it costs that much to drill the well. So it was a great proof point, but we always knew it was just the beginning. So now that I've kind of shared some of those stats on the well depth. Oh, and by the way, we knew we couldn't even go up over 400 F then because we didn't have the temperature for it. So we limited our well to just 350 F. So 350 F, 75 days, 11,000 feet total depth, 11 BHAs to drill the lateral. So that's where we started. And since you've got Kareem there, why don't Kareem can kind of pick up and tell you where we are now and where some of the big improvements have come from.
Yeah, so I think our first well at Cape Station, we were kind of building off of those wells that Tim had mentioned over in Nevada. And our first well came in right around 44, 45 days, which was in line with expectation for a first well, but obviously not where we'd want to be for a long-term commercial development. Now, 20 wells in, we're hitting 16, 17 days spud to TD. So roughly a third of our first well here in about 20.
It's a third of your
wells,
first well here, but it's, a sixth of your first well in Nevada.
Yeah. And so where that improvement comes from is there's a natural learning curve just by repetition, by doing. I would say the latest in shale drilling technology hadn't made its way to the geothermal space. So even though drilling a hole is ultimately the end product can vary, right? Whether it's a hydrocarbon resource or a geothermal resource, drilling is drilling. There had been this kind of mental disconnect of leveraging the latest in oil and gas shale technology and applying it to geothermal in order to kind of unlock that next frontier of EGS. And so that was one of the things that we leaned very heavily into. So a lot of bit and cutter technology, the latest in power in power delivery to the bit, so motor technology, obviously rig spec and the types of rigs that we were using to drill geothermal wells and past conventional geothermal, totally different than what we're using for the enhanced geothermal systems, and that's more in line with what we're doing in the shale world. So really bringing the latest and greatest of oil and gas technology and applying it to geothermal was a huge step change in performance. And I think from there you go to there's no substitute for actually doing it. So your first well gives you mountains of data in terms of how the bits fail, why the bits fail, when they fail. And we take that data and we work with our partners, with our service providers, with a wider team, and understand what do we need to do to overcome this limiter and push it to the next step. And so we went from 6 to 7 bits to drill a 5,000-foot lateral to down to 2 bits, and with an eye towards drilling in 1. And a lot of that is just taking the existing technology that we know works and then tweaking and optimizing and tinkering, like we were talking about earlier, to take it to the next level.
So that number you used before, Tim, 13 million, what's the number now?
Yeah, so I'd say less than half now. We're right in the just north of 4 million for drilling well costs. So it's I'd say the days are a proxy for cost, right? And so when you're able to cut your days substantially, that's a huge impact on overall well cost.
I was thinking, when Kareem was talking, Tim, when we first met you 3.5 years ago or so, forgive me if it was before that, but it was somewhere in there. I think geothermal used to sit in this funny space where the oil and gas people would say, "Oh yeah, we've thought about that, and doesn't really work." And the quote green community was sort of like, yeah, well, wait a minute, you guys are putting holes in the ground and fracking, so we're not so sure that we want to hang out with you either. So it was this kind of stepchild place. But now if you fast forward to today, it's just the opposite effect. The quote, it seems like the quote green community is saying, hey, this stuff is no impact, great, they're loving it. And the oil and gas community is saying, hey, these are our skills. We know how to do that. This could be a real growth industry for us. So it's just, is that, maybe I'm exaggerating, but that's the way we would replay the history a little bit.
I think that's right. And I'll give you kind of one anecdote on sort of the skepticism, particularly from the oil and gas world. And then I'll mention, the broad bipartisan support we're enjoying now. So it was always funny. I think that one of the biggest things that drove skepticism in oil and gas as compared to their embrace of other things is we were in that uncanny valley. We were just a little too close to what they did for them to really see it as the opportunity. And I actually can't tell you how many times I'd heard the direct phrase from some executive in the oil and gas industry that was, we've got teams of geologists. Like, if this was a good idea, we'd be doing it already. And they wouldn't even look at it because there was just this belief that it was so close to what they did. If it was a good idea, they'd be looking at it. And I remember one specific anecdote going back to our early days, 2018, 2019, we were trying to convince a service company to partner with us on something. And we didn't really have enough capital to justify to them, to build a special tool, high temperature tool for us. So we tried to, paint them the vision of look, if you help us get this industry off the ground, what a great market it'll be for you. And I got the answer back that, they're not going to devote any internal resources to it because they'd already looked at geothermal and it doesn't work. And I was like, what do you mean? And I ended up getting a friend that we were interfacing with there to forward me their report on how geothermal wouldn't work. And they'd hired their global, they'd worked with their global technical advisory committee and published a report on how geothermal wouldn't work. And it was dated 2003. And this was 2019 when we were having this discussion. And so I think this was a lot of the hang up is if you looked at a lot of the technical challenges that geothermal was facing and you just used, technology performance pre-shale, these wells don't look good. But once you started looking at it with a fresh sight, you saw it. So I think that's a big reason why a lot of the oil and gas community missed this. And I'll tell you, they're playing catch up now. Every person I talk to in oil and gas has a geothermal effort going on. But the oil and gas community, I think, has started to embrace this because, number one, there's power is on everybody's mind. And so everybody in oil and gas is trying to figure out how they can get exposure to the power sector. And I think number two, we've published enough of our results now that we've addressed a lot of the skepticism. And then I think the environmental community, and particularly folks focused on climate change, are embracing this as well, because it's an opportunity to produce round-the-clock energy without carbon emissions. And so what I always tell people, and I spend a lot of time in DC these days, is it doesn't matter what your energy policy priorities are for the country. If it's national security, if it's lowering carbon emissions, if it's increasing the grid reliability, geothermal does that. And so we're enjoying broad support now across the environmental community, across the business community, Democrats, Republicans, you name it. And it's really because the geothermal checks the boxes of what anyone wants to see when it comes to addressing our national energy priorities. So I think that we're in a really good position now.
Well, it's interesting. We as we went on a tour, and there are you have drilling locations here. You have the locations for the quote power plants that are fed by the wells. I think you've drilled about 20 wells here. Yeah. And then you have the substation, which is going to tie into the grid. So there's a lot to see. But we were getting the sense from your team, you get visitors of all kinds here. I mean, you get people who have never seen a drilling rig, and you get people who have maybe were born on a drilling rig. Like, so it just has sounded fascinating. Kareem, you're smiling as you guys have educated people, just the diversity of visitors you're getting out here.
Yeah, it is really exciting, and it's nice to see kind of their eyes kind of open wide once they see all the activity. Like I said, there's some folks who have never seen a drilling rig before, and that in itself is a unique and once in a lifetime experience for a lot of them. And then others who will come by and visit the rig, and it's one of many that they've seen, but they'll notice some key differences based on our operation, right? We handle fluids differently in order to cool them to keep our tools alive and extend our run lengths while we're drilling. Obviously using water-based mud, typically keep the rig pretty clean and in top shape. So you get a wide assortment of folks coming out to visit. I think every visit and being able to tour people around is really exciting, just to see that enthusiasm as they get to walk around the site and experience something that we get to experience every day.
Although we did establish this is the first podcast that has been done on site.
That may be true. Yeah.
No, I think it's true, Kareem. I think it's true.
Yeah,
it is true.
We're delighted. We're delighted. Well, I'm gonna ask one more, and Mike and Mark, please jump in with your thoughts and questions. How should we, Tim? Everybody is framing up the cost of power, and we're in an AI, world where everybody's talking about data centers and so on and so forth. But as we all know, we already had a power problem before AI. We were already thinking about power costs and power reliability and all kinds of issues. How should people think about the cost of geothermal, kind of where it is now, where it could go? And if you don't mind, maybe hit the One Beautiful Bill and how it affected geothermal.
Yeah. No, absolutely. So I think before we get to the cost of geothermal, I think it's important to remind folks of the value of geothermal. So whenever you think about the power sector, just producing electrons is part of the value. And then you have resource adequacy or capacity, which is, you also get compensated for being reliable. And geothermal has that reliability attribute. And then in also certain markets we're in, there's strong renewable portfolio standards that incentivize carbon-free energy to come onto the grid. So when you start thinking about this, geothermal has the full sort of suite of attributes of value, where we have the energy we produce, we have the reliability features, and we have the environmental features. So it's extraordinarily valuable power. And we find the utilities and our tech company customers, and our two biggest customers are Southern California Edison and then Google. So it's a mix of utilities and the hyperscaler companies that are buying power from us. We have
Tim,
what they.
can I ask you a question? If you were bracketing geothermal, is nuclear really the other flavor in that bucket, unless you include natural gas with carbon capture?
I do think so, and I think it's the right bucket to come into, because what you find is from power buyers, they evaluate. Power buyers have always bought a diversity of resources, and they always will, because they meet different needs for their portfolio. And what you find is large power buyers who are balancing a portfolio need to make sure that some portion of that portfolio comes from a round-the-clock resource that has capacity value. And increasingly, with the focus on emissions, people really want to bifurcate between emitting and non-emitting resources. And so when you look at the load profile of 24/7 and carbon-free, you're typically seeing people compare geothermal with nuclear in a category there. I would say natural gas with CCS is a good comparison. One distinction I would make, though, from natural gas with CCS is there's still more volatility and exposure, because over the life of the asset, there could be fluctuations in the natural gas fuel price. Whereas we drill our wells up front, our fuel is just the brine we produce right on site. So we have no fluctuation in the input price. So we actually see one distinction, even from natural gas with CCS to what we're doing, is customers really value that certainty as well, because there's no risk of there being fuel price volatility over the 30-year life of the asset that we market.
And how should we frame up the cost? Because
Yeah.
that was a great comment. You do need to talk about value
Yes.
before you talk about cost.
So what we're seeing in this market today, because you're seeing obviously an acute need for power, and it's particularly pronounced for reliable power. If you can provide the resource adequacy and the capacity value, is around the clock resource. And this has been true of recent geothermal contracts and true of recent nuclear comments. You're right to sort of bucket us together. The pricing is well over $100 a megawatt hour, because people really need the power and they really need the reliability. Even at today's cost structure, where we're very early on the learning curve, we can make a strong financial return at that price point. And our vision for Fervo is, even if we were to fall into a more normal price environment in the future, and you got to take a view on where's AI going to go, and are we going to fix the grid and all these things, but we think we can have a cost structure where we can support power pricing, down into the $80, $60, $50 a megawatt hour range over the next 5 to 10 years as we continue to drive down pricing. We couldn't do that today, but thankfully today the power is worth well over $100 a megawatt hour. And so we can make a good financial return there, which is why you're seeing us not tinker with demo projects, but build a 500 megawatt power plant just as our first large project. So there's definitely a good place there. And we want to keep coming down the cost curve, but that's the right way to think about the costs today. And to touch on the one big beautiful bill, that was a case where geothermal came out in a really good spot. Actually, when I formed the company in 2017, my very first trip into DC, I could get practically nobody to meet with me because nobody cared about geothermal. And I was there to complain about one thing, which is that wind and solar had gotten an extension in their tax credits and geothermal hadn't. And I said, look, if tax credits are to incentivize nascent industries that need to get their feet under them, that's us. If you're trying to incentivize something that reduces emissions, that's us. Why are we left out? It took many years for that to be fixed and for us to be put back at parity with the tax credits with wind and solar. And it was a really fascinating thing to watch the debates over the last few months about our energy policy priorities in the country. And one thing that continued to hold firm was that even under Republican leadership, they looked at geothermal as an emerging technology that needed that support to get down the cost curve, and as something that met very well with the energy priorities of the United States: reliable, fuel secure energy. And so geothermal actually got an extension through 2033 in the one big beautiful bill for our investment tax credit, at a time when they curtailed the timelines for other renewable energy resources. So I think that's just an example of there being a lot of policy tailwinds for what we're doing right now, and it coming from both sides of the aisle. We were included in the Inflation Reduction Act as a tax credit and then extended in the one big beautiful bill. So it's very clear that regardless of party or support, and the current administration has shown great leadership in this, especially under Secretary Wright, that geothermal is a priority that people are willing to invest in.
Well, it's this sweet spot, and there's only a handful of them, of things that both sides agree on. It's like geothermal, nuclear, nature-based solutions, agriculture, I'm not sure what else is in there, but it's a small box.
We love bringing the country together around a
That's
common
right.
love of geothermal energy.
Mike?
Yeah, Tim, I was really interested in, sort of the breakdown of a cost for a facility. I mean, one of the things that we've seen lately is this 50% tariff on steel. And I'm just wondering, it would seem like you probably need some specialized steel to go down there for those temperatures. What is that meaning for you? How is that raising the cost? Is that a concern for you? And what kind of like, feedback, pushback are you presenting to Washington about, sort of supporting this industry, but actually doing something that's not supporting it?
Yeah, it's a great question. And since we have our drilling manager, Kareem, here, Kareem, I don't know if you want to talk about casing selection, because it might surprise people sometimes that we're using more common casing than you would think.
Yeah, in certain areas where you may be driven to using CRA, corrosion-resistant alloys, or 13 chrome, which can require very specialized materials that a lot of times you can't find domestically. In our case, what we're able to do is use low-carbon steel, which is a commodity item, highly available domestically within the U.S. So in a sense, that insulates us from the need to look internationally for very specialty items. And with that, we've been able to source a lot of domestic pipe, and it broadens our supply base for steel, which goes in the ground. So with that, we can look at seamless pipe, we can look at ERW pipe, and we're not supply limited for steel.
Well,
yeah, I think that's an important point, because the casing, the reason I brought it up is the casing selection we need, it does allow us to source domestically. So the vast majority of the casing we've got on our project, even back before the tariffs and the one big beautiful bill, we've sourced predominantly from Valeric and a casing mill they have in Youngstown, Ohio. Actually, the Inflation Reduction Act included incentives to bring content domestic. So this is a journey. Onshoring our manufacturing is a journey Fervo's been on for many years now. That being said, obviously the tariff environment does have a huge impact on us, and it's been something that's been a challenge to navigate. The pricing of our input products changes constantly, even when we're sourcing steel domestically, like we are with our casing selection. The impact of the tariffs lifts prices for all the products. So we've been trying to manage it, but I think we have some unique advantages in geothermal in the sense that we have a much more domestic supply chain than either a lot of conventional or renewable energy resources. And given the bonuses for domestic content and the pressure to onshore from tariffs, we've been onshoring a lot. So one of the big things that we're excited about, Maynard, at the site that you visited and got to walk around today, you probably saw our air-cooled condensers out there. In phase one, we were sort of solving for speed. We needed to get the steel in the air. We sourced that from the first, the fastest supplier we could, and that ended up being sourced internationally. For phase two, that's just an example, something that makes up a meaningful percentage of the overall capital invested in the plant, and we're going to have that all manufactured here domestically in the United States. And so we're responding to the tariffs by onshoring as much of our supply chain as possible. But it definitely has been something that's taken up a lot of my time and the team's time trying to navigate the uncertainty over the last few months. But I think Fervo and geothermal as a whole has a pretty uniquely strong position when it comes to onshoring and domestic sourcing of components for the projects.
I wanted to take you guys back to a little bit of a technical question, but around flow rate. And I'm bringing it up. You've talked about drilling advances. You've talked about fracking advances. But to me, flow rate is a critical parameter in you getting the cost of a plant down in terms of how many wells you have to drill. I know you guys have made some advances there. What do you think the key to that has been? Where are you now, and where do you think you're able to go as you advance that?
Yeah, it's a great question. I think this is something that folks coming from the oil and gas industry, sometimes it's such a big departure from oil and gas flow rates that it's sometimes hard to wrap their heads around. There's just simply less energy content in a barrel of hot water than there is in a barrel of oil. And so as a result, for our projects to be economic, we have to have very elevated flow rates. And so that's been something we've designed for from the beginning. And to give you kind of a concrete example of the design changes, this drives us to do much larger diameter wells than the oil and gas industry does for a typical onshore well. So we've been doing 7-inch casing for our production liners at the site you're out today. We're also trialing for future phases going to even larger hole sizes. And that's because we target roughly 100 kilograms per second of flow per production well that we get. And that's what we really need to be economic. That translates into something like 10 megawatts of electricity per well that we drill. So that's the number we target. And to put that in oil and gas terms, that's over 50,000 barrels a day. So these are large flow rate target sites, but it's actually achievable. And we've now done this on multiple sites. And if you're coming from the oil and gas side, I think one of the important things to remember is that our reservoir drive and mechanism is completely different from production of oil and gas. Because remember, we're not trying to produce a finite volume of hydrocarbon that's in the earth. We're trying to sweep the heat out of the earth, and we're actually just recirculating fluid from injection wells to production wells. So you can maintain those flow rates if you're giving injection supports to the wells, which we are, and if you're designing with the right casing diameter in mind and creating the right permeability path. So this is one of the other areas of improvement. Our pilot project in Nevada, the Project Red, we sort of maxed out around 50 to 60 kilograms per second. At the site y'all are at today, we've achieved with our first flow test well over 100 kilograms per second. So we're getting to the flow rates we need, and they're sustainable long term because we are providing that injection support. And the biggest lever, it's amazing how much this sort of rhymes with the technology evolution of the shale days. By far, the largest lever in your toolkit to increase your flow rate per well is to drill longer laterals. And so that's what we're doing. The pilot project was 3,000 feet. So that's as much as we could handle from an equipment standpoint. We moved to 5,000 feet for the design of phase one of this project. And later this year, we'll do our first 7,500 foot lateral. So more lateral length, more flow, more economic wells. That's not too different than the story we've seen play out in shale over the last 2 decades.
Great. And one of the things I learned today when on the tour was that even though you're circulating that much water, which is a lot of water, very little of it actually is lost to the formation. I can't remember the exact number. Maybe Kareem, you maybe told me what the number was earlier.
That's right. We think when we're in sort of full production mode that we'll recover, 95 to 99% or more of the fluid we inject. And so it's really a fairly efficient way to produce electricity, even from a water consumption standpoint.
I was going to ask another question really about the long-term nature of these projects, and maybe talk a little bit about sort of how you maintain that power output over time, over a 15, 20-year time period where, I've heard people raise questions about thermal drawdown. I've heard people worried about whether or not the formation, as it changes over time, is going to be able to maintain those flow rates. Could you say a little bit about those things?
Yeah, absolutely. And I think thermal drawdown and uncertainty over the long-term production has been a huge challenge for conventional geothermal for many, many years. And to kind of draw a distinction here that I think is important is the reason that's such a challenge in conventional geothermal is if your reservoir is just what's naturally there, you don't have that many knobs and dials to turn what you're doing. So if the reservoir only has a certain amount of volume and surface area in it, and you try to pump through at a higher flow rate, you're going to cool off the rock faster and you're going to get thermal decline. So that's what happens in conventional geothermal because you're confined by what's there naturally. And what we're doing is quite a bit different because we're creating our own reservoir, and we can always drill longer laterals. We can increase the spacing between the wells. We can decrease the fracture spacing, so you're getting more fractures in the rock, and we can adjust the flow rates up and down. So we have far more engineering controls than traditional geothermal does. And so the think about long-term production, you think about why would production go down? There's really two main reasons for it. Either your flow rates go down, which is what you see in oil and gas, usually, especially for the primary production phase, or your temperature goes down because you start cooling off the rock. In geothermal, it's actually quite a bit different story on the flow rate standpoint for the reasons I mentioned before. You're actually providing injection support from day one. So you're not drawing down the pressure of the reservoir. So we have very limited changes in flow rate over the long-term life of the reservoir. And so thermal decline is really the name of the game in terms of what would drive a thermal decline in this, a production decline in the system. And so what we do is essentially try to set the well spacing and the lateral length so that each well system will produce close to its nominal sort of temperature and power output for a 10 to 15 year period, and then sort of enter into a longer period of decline. And the way we really plan to manage that decline over time is we always keep in inventory a large number of makeup drilling locations. And the plan is 10, 15, 20 years into the project to start retiring the cooler wells and supplementing it with the drilling inventory. So it's quite a manageable problem from a production decline standpoint. And if we end up finding different areas where the thermal decline properties are higher or lower than the project that we're working on right now, we can always adjust that by increasing lateral length or spacing or decreasing flow rate. And we've got a lot of very robust modeling results to support this. And I think what's great too is we've got some field data behind this as well. I mentioned our pilot project in Nevada. We brought that project online in October of 2023. And so we're nearing 2 years of production there with a flat temperature profile, which has been a great data point to sort of put to bed some of the fears around premature thermal decline of these projects.
Tim and Kareem, we had a great time at this site. I think your team said there's maybe 250 people here, working involved in all aspects of this. And we're in phase 1 and 2 so far, but ultimately this is going to be a bigger complex. Could you talk about the vision of this site and Fervo, sort of 5 years out, like how much power is coming, how you'll be expanding?
Yeah, well, we're trying to meet the moment as fast as we can. Like we mentioned, the demand for power from AI, from utilities, from anybody trying to secure their energy mix is immense right now. So the site you're on today, we're developing it in 2 phases. The power plant's in active construction, and most of the wells have already been drilled for phase 1. So that's 100 megawatts that we anticipate commissioning in 2026. And then we have an additional 400 megawatts that we call Cape Phase 2 that we plan to commission in 2028. So we're already kind of doing some of the early planning for that. And we drilled some of our first appraisal wells for that expansion earlier this year as well. Just for some numbers, we've now gone through the work to get sort of third-party reserves audits on the resource there. So we'll produce that 500 megawatts from actually a very tiny portion of the overall acreage position we have in this central Utah location. And so ultimately, we think the reserves there support expansion up to at least 5 gigawatts just from that one site. And so we're trying to work through right now plans to bring customer load, whether it's a data center or otherwise, to the region to use the power, and also expanding the transmission lines in the area to get more power out. Fervo is the largest acreage holder of geothermal development rights in the country by a pretty significant margin. And so we have another dozen plus sites in our portfolio that share very similar characteristics to the Project Cape site that you're on today. So we anticipate, breaking ground and beginning development of multiple different multi-gigawatt basins throughout the Western United States in the coming years.
So Tim, tell us, how does the leasing of those rights work? Who do you lease them from? Is it usually private land or federal land or state? And what does the owner sort of get from you if they sign that agreement?
Yeah, so it's a mineral right. It functions very similar to oil and gas mineral rights. In our case, we're fortunate that there's federal law that clarifies the definition of geothermal. The Geothermal Steam Act of 1970 passed. This is actually a big challenge if you go develop internationally, is sometimes people don't know what the jurisdiction or what the ownership of the geothermal rights are. But in the U.S., it's clarified. It's a mineral right. There's a federal definition for it. It's consistent across the states we operate in. So it works a lot like oil and gas. If you think about the states we're in, we're most active in Nevada and Utah. Those states are somewhat unique in the U.S. in the sense that, like some other Western states, the largest landowner in those states is the U.S. federal government. And so just sort of by default, where we've gone because the geology's perspective are the same states where the U.S. federal government has a large landowning share. So actually the majority of our portfolio is the U.S. federal government. So we go through the Bureau of Land Management lease auction process to acquire most of our acreage. Beyond that, we have a large amount of both state and private land too. And it works very similar to running a leasing program in oil and gas. It's, approaching landowners, making the case. The structure is quite similar too. We typically pay a rental fee while we're in the pre-development phase. Then when we move into production, it's a royalty based off of electricity sales.
I think as we were talking about it today, guys, you have all this, the uniqueness of the geothermal and everything you're doing. But once you get it to, is it isopropylene?
Isopentane.
Sorry, isopentane that you're using to drive the turbine. My point is, once you get to the turbine, from there, everything looks, quote, like a standard power plant, right? So you have, however you're getting your heat from the turbine forward, now it looks, quote, like a typical power plant. We hear all the time about the problems getting turbines, getting all the infrastructure you need to build a power plant. Are there supply chain constraints on you to grow just like everybody else in that respect? And are you worried about what those costs could do to your costs, just like they're inflating natural gas plant costs and other plants?
Yeah, it's a great question, and we are somewhat exposed to that. Although the run up in cost has not been as significant as what you've seen on the natural gas turbine and power generation side. It's an interesting.
Is your turbine is the same turbine that a natural gas plant would use?
It's a slightly different turbine. The organic Rankine cycle system do require a bit of a different turbine design. So we're very excited that the place we're partnering, our equipment supplier for phase one of this project, the turbines and balance of plant that you see on site, is Mitsubishi Heavy Industries. And through a subsidiary they have called Turboden, they've been manufacturing geothermal organic Rankine cycle turbines and power systems for about 40 years. So it's a very proven technology. Thankfully, in this moment, has a bit of a different supply chain than the natural gas turbine supply chain, which means that it's not quite as strained as the natural gas market is. And so we definitely are subject to some supply chain constraints. We've worked very hard with our partners to ensure a big ramp up of turbine capacity is going to be there over the coming years. Transformers and high voltage electrical equipment have been a pain point for us, just like any other developer, but we've got kind of a good multi-year pathway on that. So yeah, we're in some ways subject to the same supply constraints as other developers in the power sector, but we've gotten out ahead of the problem through a lot of early procurement, and then the fact that our turbines are slightly different and share a different supply chain and manufacturing base than the natural gas turbine market means we're not subject to the same sort of inflationary pressure and extension in lead times that industry is undergoing right now. So from a time to market standpoint, we're in a really good position, and that's why you're seeing a lot of the interest in geothermal right now.
What are the permitting considerations, and also how steep is the learning curve when you step away from what you've done here very locally in terms of what that might turn into in terms of costs or project risk?
Yeah, it's a great question. Permitting usually takes a long time. Although it is improving, it has improved significantly over the last few years, but we are developing mostly on federal land. And so as a result, we sort of do a full NEPA review for all these projects, and geothermal is sort of uniquely disadvantaged in this case because we have to do multiple sequential NEPA reviews for the same project. So, the project site you're on today is, we had to do 4 different NEPA reviews in sequence in order to be able to build the power plant there. So the permitting timeline took about 5 years. What we're seeing is administrative actions and legislative actions. There's a big focus on shortening those permit timelines right now. And so we're seeing the fruits of that come to bear with faster permitting timelines, but it still is kind of one of the longer poles in the tent for development. So we've actually gone forward and started permitting processes for many different locations throughout our portfolio already throughout the Western U.S. So we could sort of get the ball rolling on it. So that's sort of the answer to that first question. Still a challenge, but improving. There's definitely been significant improvements in permit timelines in the last couple of years. On the applicability standpoint, it is interesting because a lot of the things Kareem talked about there on the drilling side are what we would consider to be global learnings, not local learnings. Drilling through granite and adapting the bit to handle the harder rock is something that we make the improvements on at Project Cape, and we can apply it to the next place where we go drill through granite. Similarly, making improvements to increase the durability of our drilling process to the high temperatures can be applied globally as well. So like with any new resource play, we think moving to some of these other areas in the basin and range throughout the Western United States, it will require appraisal drilling. It will require some tweaking to sort of match the performance of the unique geologic and reservoir conditions of the formation we're targeting. But so many of the things that we've now developed for dealing with the high temperatures and dealing with the hard rock will apply one-to-one for these new locations. So we believe there's a strong element of global learnings here that will translate to lower prices across the entire future development portfolio. Even if there's going to be some variation from site to site.
Beyond the Western United States, are there other places in the U.S. that are viable? You mentioned at the beginning the Eagle Ford and Haynesville. Is that an area that has potential for geothermal with this kind of approach?
Absolutely, and I think it's all a question of resource quality and cost. The way we think about it at Fervo is we design our power plants to work at 400 to 450 degrees Fahrenheit. If you want to know how much it's going to cost in a place, figure out how deep do you have to drill to reach 400 degrees Fahrenheit, and you can sort of address your cost that way. So right now we're focused on Nevada and Utah because those are where the projects are in the money at today's cost per foot structure, where no further improvements are needed to develop gigawatts of power there. But we don't expect to slow down in terms of our drilling cost performance. We're still, you compare, I think the stat I heard last week was that the U.S. oil and gas industry drilled 8,000 oil wells last year and has been doing that for decades now in terms of shale. In geothermal, we've now drilled about 20 horizontal geothermal wells, and Fervo's drilled almost all of them. So we're still very, very early on this cost learning curve. And what I think is going to end up happening is we're going to see significant reductions in cost per foot in the coming years, where all of a sudden going to a market like Texas, going to a market like Pennsylvania, going to international markets, even if you have to go much deeper than the 8,000 or 9,000 feet we see in Utah, is still going to be an attractive spot on the supply curve. So it's purely a function of how quickly can we drop that cost per foot of drilling. And we're very optimistic based off of the improvements we've seen to date.
Yeah, Tim, I think one of the big things that we've seen in the market is, be it nuclear stocks or whatever the case may be, some of these big, long 10, 20-year PPAs being signed. You mentioned earlier that you're confident that you're sort of in 100 megawatt, and you probably over time could probably get it down to $60 to $70 a megawatt. How does that sort of factor you getting your prices down, your cost down, to you eventually entering in some of these PPAs and giving you confidence to do something longer term? So maybe talk about where you are right now, how things develop from a cost standpoint, and when do you start approaching some of these companies and basically striking these PPAs that are long dated?
Yeah, we're already there, I should say. We've got over 15 PPAs executed as a company. It covers over 600 megawatts of development, some at the site that Maynard and team are at today, and some at our next locations that we're going to. And all of our portfolio is 15-year PPAs or longer. And so, there's enormous demand in the marketplace for the product we're selling and doing 15-year binding offtakes. And I want to point out too, because there's a lot of companies that are sort of in this emerging new energy space that will promote non-binding LOIs or MOUs or press releases around this. When I say a PPA, what I mean is this is 600 megawatts of binding take-or-pay offtake agreements that have been approved by the public utility commissions in the states we're operating in. So these are real offtake agreements, and we expect to sign quite a bit more. And I think that's just a reflection of where we are in the market. How acute the need is for this power, and the fact that we already have our cost structure in a place that gets the power to a price that our customers are very excited about. And so the way we think about this, the lower we drive the costs, that's more geographies we can go to and still be cost effective. That's, if you have a price point on a customer that may have a lower willingness to pay, that kind of opens up that resource base. But we have had no trouble at all, executing now several billions dollars worth of binding 15-year offtake agreements across a diverse set of customers.
I was thinking, Tim, as we wrap up, and Kareem, again, thank you guys so much. Your team here was so nice, thoughtful, and they gave us a lot of time and answered so many questions. So again, thank you. I was thinking, you've solved so many issues, or you've made so much progress since we first met you, right? Like you've had some really successful fundraisings. You're proving up the concept in so many ways. You're driving down costs. The attitudes have changed out there. You've educated a lot of people. There's been so many things that you've done. As you think about just like the next year or so, 18 months, what are the main goals or challenges or things you're trying to do to advance the story? Like what's on the top of your to-do list?
Number one is always execution. And I think that's one of the things that's gotten Fervo some credibility over the years is we say we're going to deliver a pilot and we deliver it. We say we're going to come down on drilling costs and we do it. We want to deliver Cape Phase 1 and we want to do it, on time, on budget. And that's what we're laser focused on right now. And we want to do the same for Cape Phase 2. And we want to do the same for the rest of our portfolio. So I think more megawatts.
Tim, Cape Phase 1, what is that date?
Should 2026. It's coming later next year.
Okay. All right.
Yeah, so it's just around the corner. And I think the more megawatts we have on the grid, the more we're going to convert believers. So that's a big focus of ours. I think one of the other things that we're trying to do right now is make sure that we're in the conversation. I'm still to this day in so many conversations where people say, well, the solution has to be this because there's nothing else. And they'll name, pick your favorite, energy technology of the future. And oftentimes it's folks that have completely glossed over geothermal as an option. And frankly, it's a lot of times people who, commissioned a report about geothermal in 2003 and haven't updated their assumptions yet. And I was just talking with a national lab researcher we work with who's trying to put together a good story on how quickly we've dropped the cost structure. And he said that he was telling some market folks recently that if you're looking at the geothermal story and you're using any cost estimates that haven't been put together in the last 6 months, your numbers are so wildly out of date, you're going to miss the story. And I think that it's amazing. There's still an awareness issue. And I think people need to realize this is going to be a major solution for power generation going forward. And it's not look, we're going to do 18 more things. And then in the mid 2030s, our cost structure is going to be fine. It's an attractive cost structure today that's going to just get even more attractive in the future. And I wish there was just more awareness about that.
One thing that's interesting is when it comes to geothermal, like you guys stick out, but there aren't a lot of other names. But if you said, micronuclear or SMRs, for instance, just to take nuclear, there's lots and lots of them. So do you think it's almost a disadvantage that you're a pioneer and there aren't a lot of other pioneers in your space? Yeah,
I would say that it's certainly a disadvantage when it comes to generating hype because there's just fewer voices speaking up about it. Although I will say, if you look at companies that we like to compare ourselves against, like SpaceX, for example, no one today says that, is the industry disadvantaged because it's only SpaceX launching rockets? Wouldn't it be better if there were 10 other companies doing the same? So I think over the short term, it hurts us from not generating the same buzz that some of these other industries do. But over the long term, I think we're very excited about our differentiated position and the jump start we have on anybody else in the geothermal space. So I think it's going to serve us well over time.
It reminds me in oil and gas, there used to be one guy in a basin, but once there were 10 companies in the basin, the thing would get more airtime or something. But well, you guys are nice to endure our analogies and our questions and spend time with us. Kareem, thank you so much. Tim, your team's awesome. We've had a great time. And for all of you watching, please reach out to us or certainly the Fervo team. Don't drive them crazy. They'll blame us. But we've had a great time here and there's a lot to learn, a lot to be excited about. Thank you.
Yeah. Thank you so much for having us. It's been a very fun conversation.
Awesome.